Movie physics are known to be notoriously bad, so let's take a look at them in the movie Hunger Games Catching Fire.
Katniss, you might not know this, but in your final scene in the movie, where you shoot the arrow to the top of the dome, would probably not have worked due to real-world physics. You probably would have died. How do you feel about this?
Well, you know, I wouldn't believe you.
Now let's take a look at how forces would affect it from a physics standpoint in the real world. To answer the question from the beginning of the video, we need to find the net force that acts on the arrow from gravity and air resistance. These would cause a negative acceleration, which would cause the arrow to slow down and eventually stop. However, in the movie, the arrow does not seem to slow down at all.
In our case, the force of air resistance can be represented by this equation. It is the drag coefficient multiplied by the density of air, multiplied by the cross-sectional area, multiplied by velocity squared, all divided by 2. Using Google Magic, we found the drag coefficient is 0.5 for arrow-like objects. We found out that the density of air in Hawaii, where they shot the Hunger Games, is 1.1839 kilograms per meters cubed. In the behind the scenes, they revealed that Katniss uses a recurve bow with Easton arrows. The arrow she uses weighs 11.68 grams. High-end recurve bows can shoot at a speed of 106.68 meters per second. Plug everything into our equation and we get this!
Force of gravity, in this case, since they're in Hawaii, would be 9.78 meters per second squared times 0.01168 kilograms. After this, we can add the two forces that we need together, and then we can get the total net force. So we know that F net equals m times a. So we can take a, acceleration, and put it into one of the big 5 equations. So the equation we'll be using is delta d equals v1 times delta t plus half of a times delta t squared. The only variable we have left to solve is time, but however, we can just watch the movie. From watching the movie, we determined that the scene is 5.5 seconds long. So using the numbers that we have already found, we can just plug them all in and then we can find the total distance the arrow traveled.
One other thing we should kind of point out is this lightning strike. Did you know lightning travels at a speed of roughly 6,000 kilometers per second? That means this dome is nearly 7,500 meters tall. Maybe we should tell Katniss about our arrow throw. You know, Katniss, after 5.5 seconds, after your bow has been shot, your arrow will be over 500 meters below ground. What do you have to say about that? As you can see, Katniss,
it's not possible.
I'm sorry to say, Katniss, but your arrow will barely even go 8 meters up into the air, let alone the 30 meters of the trees. Katniss, you really have not survived these Hunger Games.
I'm Kai-chan.
And I'm Kevin.
And hopefully we taught you today that movie physics is usually bad physics.
So thank you so much for watching this video. If you did like it, be sure to give it a thumbs up and subscribe to this channel where I'll have more videos like this. In fact, I had other educational videos in the past, like this one. Anyway, bye!